Hello everyone, my name is Mingyang Zhou. Today I'm going to introduce our work on supervised vision and language pre-training while retrieval-based multi-granular alignment. Vision and language pre-training has achieved tremendous success over the past few years. This technique allows us to learn robust cross-modal representation from large-scale parallel image text corpus while self-supervised learning, and the learned representation can generalize well to handle various downstream vision language tasks. Previous V+L pre-training work mainly used human-annotated image capturing datasets such as MS-COCO or noisy image text pair script from internet like conceptual captions as a pre-training corpus. However, there are even larger amount of unpaired image or text corpus such as book corpus and JFD 300 million that can potentially introduce more multimodal context and knowledge, but are not well explored to help vision language pre-training. Thus, take a step further. In our work, we explore to learn robust vision language representation from the unpaired image and text corpus. We propose a two-stage pipeline to learn cross-modal representation from unpaired data. First, we format a weakly aligned image text corpus by retrieving text that contains similar semantic information as a given image. We then propose multi-granular cross-modal alignment during pre-training, where we capture cross-modal alignment in three different granular, including region object tag alignment, region noun-phrase alignment, and image sentence alignment. For unpaired image and text corpus, we find that there are still latent alignment between some text and images. For example, although the four sentences on the left are not strict captions of the given image, we can easily tell that the first two sentences are more semantically related. This is because they cover more visual objects depicted in the image. To capture such latent alignment, we build a retrieval process to select texts that cover as much visual objects in the query image as possible. First, we leverage a pre-trained object detector to extract the object tags from the image. Then we pass a list of extracted object tags and all the candidate tags through a pre-trained sentence BERT model to obtain their vector representation in a shared embedding space. Finally, we compute the cosine similarity between the embedding vector of the object list and the candidate text to find the weak aligned text to the image. Next, we pre-train our model to capture multi-granular cross-modal alignment from this formatted weakly aligned data with three types of training. First, we propose to align object tags onto the image regions. We pass a pair of detected object lists from the object detector and the source image to the model. Then we randomly mask out object tags or the detected object regions, and apply masked language modeling and the masked region modeling objectives to teach a model how to interpret the masked concept from the context of its counter modality. We also propose to align the noun phrase and the image regions to generalize the local cross-modal alignment to more vocabularies. Given a pair of weakly aligned image and text, we first detect the noun phrases, and then assign the noun phrase to a detect the bounding box as a pseudo-label if the word-to-vec similarity between the noun phrase and the object tag of the box is higher than a certain threshold. During training, we randomly mask a detected noun phrase or bounding box region. Then we apply masked language modeling and masked region modeling to predict the masked noun phrase or the assigned pseudo-label. Finally, given the weakly aligned image-text pair, we apply image-text matching task to capture instance-level cross-modal alignment. We consider the weakly aligned image-text pair as a positive case, while the randomly sampled image-text pair as a negative case. We denote our method as MuVLA, and our unpaired pre-trained data are sampled from conceptual captions without using the original image-text pair information. We compare our method to the previous state-of-the-art unsupervised V+L pre-training method, UVL-BERT, as well as the supervised method aligned VLP, which uses the same pre-training features and model architectures, but pre-trained on parallel conceptual caption data. As can be seen from the table that we have outperformed UVL-BERT by quite a big margin and are very close to the performance of the supervised approach. It demonstrates the effectiveness of our proposed method to learn robust cross-modal representation from unpaired data. In summary, we show that by formatting weak alignment between unparalleled data and learn the cross-modal alignment in multi-granular perspective, we can learn robust cross-modal representation similarly as the supervised V+L pre-training method. For more details, please refer to our paper and code and bring your questions to our poster session. Thank you.